Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Problem 74. A closed tank contains gasoline of specific gravity 0.68. The gasoline surface is subjected to a pressure of 138 kilopascals absolute. Remember, this is kilopascals absolute. Horizontal pipe 25 mm in diameter is 1.5 meters below the surface of gasoline, and the end of this pipe is exposed to the free atmosphere. The losses in the exit pipe is K, loss coefficient capital K times velocity head in the system or in the pipe. If the discharge is 2 liters per second, determine the value of K. So for our solution, let's have to draw the diagram to help analyze the situation. So we have a closed tank which contains gasoline of specific gravity 0.68, and the pressure in the gasoline surface is 138 kilopascals absolute, and we have a horizontal pipe 25 mm diameter and 1.5 meters below the surface of gasoline, and this is exposed to the atmosphere. So the losses in the exit pipe is given by this expression, loss coefficient times velocity head in the pipe. Then if the discharge is 2 liters per second, determine the value of K. So we can compute the value of velocity, then the velocity head. So we write energy equation between zero point 0.1 and zero point 0.2, and we consider absolute pressure. So consider that 0.1, this one 0.2. So velocity head at 1 plus pressure head at 1 plus elevation head at 1, then equals velocity head at 0.2 plus pressure head at 0.2 plus elevation head at 0.2 plus head lost from 1 to 2. So we select the datum to pass through 0.2, so that elevation head at 2 is 0 and elevation head at 1 is 1.5. So velocity head at 1 is negligible. Pressure head is 138 kilopascals over 0.68 times 9.81 at 1. At 2, it is atmospheric, so 101.3 kilopascals absolute over 0.68 times 9.81. And V sub 2 is V square over 2G. So V sub 2 is just V. So 0, by the way, V2 is V equals 4 times 0.002 over pi 0.025 squared. The discharge is given 2 liters per second or 0.002 cubic meter per second. So V or V sub 2 is equal to 4.0744 meters per second. Then let's compute the velocity head, V2 square over 2G or V square over 2G divided by 19.62, 4.0744 square over 19.62. That's 0.8461. Then substitute into this equation, 0 plus 138 over 0.68 times 9.81 plus 1.5 equals 0.8461 plus 101.3. Pressure at 2 atmospheric, so 101.3 kilopascals absolute, because this is absolute also. So divided by 0.68 times 9.81 plus elevation head at 2 is 0 because the datum we selected passes through 0.2. Then the head loss, which is loss coefficient capital K times velocity head, which is 0.8461. So from here we can solve K, and K is equal to 7.275. Problem 75. In the water flow over the spillway, the velocity is uniform at sections 1 and 2 and pressure approximately hydrostatic. 75.1. Neglecting losses, compute V sub 1 and V sub 2 assuming 1 meter width into the screen or into the paper. 75.2. If losses were considered and are equal to 0.2 of the velocity head at 0.2, determine the energy lost in kilowatts and horsepower. So the figure is given, and this is the figure. We first for our solution. So we select points here and here, call this point 1 and this one as point 2, and we write energy equation between points 1 and point 2, points 1 and 2. So we have velocity head at 1. First part is we ignore losses or neglect losses, plus pressure head at 1 plus elevation head at 1 equals velocity head at point 2, pressure head at point 2 plus elevation head at point 2 plus head lost from 1 to 2, which is in the first part 0. And we select datum to be at the base of this spillway, so that elevation head at 1 is 6, elevation head at 2 is zero point 0.9. So substitute. By the way, P sub 1 pressure head at 1 and 2 would be 0 because they are exposed to the atmosphere. So velocity head at 1 plus 0 plus 6 equals velocity head at 2 plus 0 plus zero point 0.9 plus 0. So from there, we have V sub 2 square over 2g minus V1 square over 2g equals 5.1. Then we relate V1 and V2 by the continuity equation. Q1 equals Q2. So since we consider 1 meter width into the board, 6 times 1 perpendicular to the screen times V1 equals zero point 0.9 times 1 times V sub 2. So V sub 2 is equal to 20 over 3 of V1. Substitute here in this equation. 5.1 equals quantity 20 over 3 V1 quantity square over 2g minus V1 square over 2g. So 2g times 5.1 or 19.62 times 5.1 equals 391 over 9 V1 square. So from here we can compute V1. V1 is equal to 1.518 meters per second, and V sub 2 is 20 over 3 of 1.518. So V sub 2 is equal to 10.12 meters per second. For the second part, we consider uh, losses, and we compute the energy lost in kilowatts and horsepower. So we write again energy equation and consider losses this time. So we have velocity head at 1 plus pressure head, which is 0, elevation head 6, velocity head at 2 plus elevation head, pressure head 0 plus elevation head 0.9, then the head loss is 0.2 of the velocity head at 0.2. Combining like terms and simplifying, we have 5.1 equals 1.2 of velocity head at 2, and velocity at 2 is 20 over 3 v1 square over 2g, then minus velocity head at 1. Simplifying, so 19.62 times 5.1 equals 157 over 3 v sub 1 square. So from here we can solve v sub 1, and it is equal to 1.383 meters per second. Then v sub 2 or Q is discharge 6 area of section 1 6 by 1 times V1 1.383, so 8.298 cubic meter per second. The power lost is discharge specific weight of water times the head lost. So discharge specific weight of water times head loss, or weight flow rate times the head loss. The head loss is zero point 0.2 of the velocity head at 2. So we need to compute V sub 2 first. 20 over 3 times V1 1.383. So it is 9.220 meters per second. Then substitute. Power lost is 8.298 times 9.81, and the head lost is zero point 0.2 of 9.22 square over 19.62 V2 square over 2G. So power lost in kilowatts is equal to 70.54 kilowatts. Then in horsepower, we divide this by 0.746 horsepower, 0.746 kilowatts per horsepower. So dividing this by 0.746, power lost is equal to 90.56 horsepower.